Now that we've defined our primary basket, we can go ahead and define our emergency basket. The emergency basket it looks similar to the primary basket. It's basically the same list of tokens that I can choose from. But in this case, these tokens that I'm going to choose now, or this basket that I'm going to choose now, is going to be used only in the case of an emergency. I'm going to take you back to the byteboard for a second before I select these tokens here, and I'm going to show you exactly what the emergency collateral is and how it gets deployed. I've set up a scenario to show you exactly how the emergency collateral in the reserve protocol gets deployed and why it's even there in the first place. In this example, I have set up an RToken, which is backed by 3 yield-bearing collateral tokens, each 33% of the weight. And I've also defined an emergency basket, which is a simple basket of a bunch of stablecoins. Now, the emergency basket only gets used, obviously, when there's an emergency. And the emergency is when a default is detected in any of the collateral tokens. What this means is, for example, a protocol hack, like the underlying compound or Aave markets get hacked, or a bug being exploited in those underlying contracts, or a depeg in any of the stablecoins used. So there's various reasons that could cause one of these collateral tokens to lose peg, and if that happens, it's called an emergency and something needs to happen, and that's what I'm going to show you now. The way the protocol detects these defaults is as follows. Each collateral token has, in their collateral plugin, has a reference asset and a target asset. For example, if the collateral token is CUSDC, then the reference asset is USDC and the target asset is USD. In this case, the protocol does 2 default checks. It checks the relationship of the price between CUSDC and USDC, and it does the same for USDC against USD. For example, CUSDC is designed to increase monotonically against USDC. So if at any point in time the price of CUSDC would start decreasing against USDC, that means that there's a hack in the compound smart contracts or a bug is being exploited or whatever. In that case, the protocol will raise the default flag, and we're going to look, in a second, we're going to look what happens then. The same happens for USDC against USD. The protocol expects a relationship of a one-to-one relationship between USDC and USD. If that does not happen, so if, let's say, USDC starts decreasing against the value of USD, then there's a depeg going on, and also some action will need to be taken. Now let's look at an actual scenario of how this might play out. In this starting position, we have our fully collateralized RToken. It has a market cap of $300 million, backed by these yield-bearing collateral, so each has 100 million in backing. You can see we also have a staked RSR pool of $50 million. And we have our emergency collateral tokens. What happens? If the protocol starts detecting a default, the way that will look is like this. You can see suddenly this basket is no longer 100 million each of these collateral tokens, but the protocol detects that this CUSDC token only has 98 million of value in the RToken basket. So that means that in this case, either CUSDC is depegging or USDC itself is depegging and trading at 98 cents. So now the protocol detects an issue, a default. One more thing I should mention here is you can see that in this case, we have what's called a diversity factor of 3. The diversity factor is also something you define inside of the register UI. And the diversity factor basically says how many of these emergency tokens are we going to use to replace this faulty collateral in the case of a default. So in this case, we're going to use all these stablecoins. If the diversity factor would be 1, then we'd only use true USD in this case. Okay, so we've detected a default. So at this point, the reserve protocol wants to protect the RToken holders itself, and so it's going to take some actions. What is it going to do? It's going to launch auctions. And these auctions, in these auctions, it's going to do 2 things. it is going to trade out that $98 million worth of CUSDC for those emergency collateral tokens. And because the diversity factor is 3, it's going to want an even number of each of these stablecoins. Now, you can see that right here, there was $98 million of value, but we're only trading it for $90 million of these emergency collateral. In this example, I'm accounting for the CUSDC, so the faulty collateral, trading at a discount at these auctions. Because even though right now it's trading at 98 cents, during the course of the auctions, it might lose even more value. And so I've accounted for trading at only 90 million in total. So if that was just the case, the RToken itself would be pretty safe because we've now traded out that defaulted collateral for the emergency collateral. However, there's an issue because now we have a hole of $10 million because we used to have $100 million in CUSDC, and because of the default and the auctions, we now only have $90 million in value. And so the RToken is no longer fully collateralized. So this is where the protection mechanism of the RSR over collateralization comes in. What's going to happen in this case is the protocol is going to take $10 million from the staked RSR pool, and it's going to use that $10 million to buy the additional collateral it needs to fully re-collateralize the RToken. So again, it's going to launch an auction, and it's going to trade $10 million worth of RSR for 3.3 million of each of these stablecoins. After that scenario, the RToken will be fully collateralized again. So in this case, we're going to have a total market cap of 300 million still, but the RToken will no longer be backed solely by these yield-bearing collaterals. It will be backed by those that were still safe, that did not depeg or did not see any issues, and it will also include those emergency collateral tokens with $33.3 million each. Now, obviously, our staked RSR pool is now less. So our over-collateralization pool has gone from 50 million to $40 million. Now that we know how the emergency collateral gets deployed for an RToken, we can go ahead in the deployment flow and we can select our emergency basket. I'm going to choose 3 simple stablecoins as in the example before, add them to the emergency basket, and you can see some extra fields appearing, such as the diversity factor, which I also talked about before. Again, the diversity factor means how many of these emergency assets are we going to use to replace the faulty collateral with, in the case of a default. You can see that there's also an ordered list of these emergency collaterals. So there's a certain priority that gets defined for them. The reason for that is imagine the situation where diversity factor is 1. Then the protocol will only choose one of these assets to replace the faulty collateral with. And so it will choose DAI, the number 1 in this list. However, the reason why you can define more assets even in that case is because the protocol is smart enough to detect a default even in the emergency collateral. So let's say in our previous example that CUSDC depegged. The protocol will then try to trade it out for DAI in this case. However, imagine if in that scenario DAI will also be defaulted, would also be depegged, then the protocol will be smart enough to skip DAI. And so instead it will go to the next priority in this list, which is USDC in this case. And even if USDC would be depegged in that emergency, the protocol will be smart enough to use USDT to replace the faulty collateral. Now that we've defined the emergency collateral, we can go ahead and look at revenue distribution in the next video.